Afternoon. It's time now to get started with the last session of the day. We'll have three presenters. The first presentation will be a virtual presentation from Utrecht by our two presenters here. And after each presenter, we'll have a chance for some questions if there's time. So what I'd like to do is introduce the first presentation, Erik Dobbelstein and Egon Verharen from SurfNet to talk about rich group communications. It's all yours.
All right. Thanks, Dad. Good afternoon, everybody. My name is Erik, and this is Egon Verharen. Egon will be assisting me locally, and this is Maurice Dome. He's somewhere in the room, and thanks for setting this up in Poland. I couldn't come personally, so I hope you are happy to see me this way, just as I am, because I'm glad that I could do it this way. All right, I will be talking about a setup that we use at SurfNet to bundle a couple of communication tools, and I'm going to show you which tools they were and how that they were being used and what we are going to do in the future with these tools, because this was a pilot and we are setting up our minds about continuing this pilot as a real production service. I wrote a paper on this subject which will also be used in the task force, the MENA task force about video and video conferencing, in which we are also looking at ways to enable users with real-time communication tools. I will elaborate some more on that later on. Excuse me. Just as many of you, SurfNet is a wholesale company, so our customers are institutions. We usually have a couple of contact persons, and we are used to selling our services by talking to these people. But we discovered that it's very important to stay in touch with the end users of our network as well. That has proven to be especially useful in case of promotion campaigns and campaigns on security on the internet, of which you could have seen some examples, I believe, this year and at least last year for virus scanners on your laptop and stuff like that. Well, that's one example, and we are shifting more and more onto the end user services that we envision in this pilot. So in this case, we do not have 150 customers, but about 750,000, which is a lot more. So we need to set up our services, which are basically applications on application level, to be able to deal with this huge amount of users. So we need a scalable solution, which is still able to react in real time. This pilot was set up in collaboration with Kennisnet, which is our partner for all other forms of education that we do not provide our services to, so especially primary and secondary schools. So basically, people have used this environment on every level of education, and we could see that on every level there are different needs, but also some are the same, which is very interesting if you consider using a real-time communication tool. So, considering this huge amount of users, what should we do to provide them with the services we think they need and that they indicate they need? Our goal in general is to be innovative, and though there are some commercial real-time communication services, there are none that bundle a couple of tools that we think are very useful to join up. Another one is to provide an economy of scale to our customers. It might not be useful for one institution to buy a very expensive MCU with a web environment, but it could be if we could buy it and provide the service to more of our customers. And another example of an advantage that we can offer is the middleware that we are already putting into place. You all probably have heard of AG-Roam, which is especially useful for network access. And you've heard probably of A-Select, which is a distributed authentication mechanism for web-based applications. once these are in place, you could easily put them onto these services, so people could use their existing institutional account and enter these services. And another thing that we could provide, which could be useful for universities, is white labeling. So we could set up the service and we could allow them to provide their own template and their own logo, etc. So it would feel like it would be their own service, basically. So this is the suite as we have composed it. It basically consists of three components which are readily available on the market, but all have gone through an intensive process of development, and they still are actually. I will go into them in more detail separately, but the way they are ordered here already indicates how they are set up. On the top you can see a web environment which is a very well-known environment. It's Microsoft SharePoint, and there are many similar products on the market and also open source available. And it's basically a web-based environment in which you can store documents and do some non-real-time. It's a bit of a difficult definition, but let's say it's a non-real-time environment. The lower two components are more real-time. The left the one below left is actually the one that I'm presenting through at this moment. It's Click to Meet by FEC, which is purchased by Red Vision lady. And right on the lower right side is Microsoft Live Communication Server, which is accessed by Windows Messenger. And with the yellow arrows, I've tried to show the relationship between them. We actually didn't do much to couple the products, but they all had some features which enables users to easily switch between them. And we intend to integrate them much more in the future, of course. Some examples of how we did that will be shown, of course. This is basically an arrangement of all the tools that you can see today, and the way that we've defined them within a matrix and put them opposite of each other, especially when we talk about synchronous and asynchronous tools. I will stop using the term real-time now, because the upper already shows that it's more about synchronous communication. If I tell something, then you can hear me, and if you would ask a question, I could immediately respond to that, as opposed to the lower row, in which we have asynchronous communication tools. You don't need to be online at the same time in order to communicate. That's the big difference. And all the green components that you see are services that SurfNet already offers today, and all the other ones are items that were mentioned by customers or that you can clearly see that are becoming important, especially between students. Students are often a very good case of future prediction. So what we try to achieve basically is to integrate all these components into an environment, and I think we did a pretty good job with the pilot setup. So integration is the keyword in this case. It's not enough to provide a group like MSN does or Yahoo Groups does it. They are very useful, absolutely, and we want to build more on top of that, basically. And we want to make every means of communication available through this web portal, as you could name it. And also we want to support as many forms of use. So we investigated what kinds of scenarios in which these tools were useful. And one of them proved to be a lecture, which you can compare to this specific session. But it was especially useful in case of project-based education, when students are distributed over different institutions, for instance, and they were not able to access all the same document stores, for instance, at one institution. It is also very useful if people decide to join up on an ad hoc basis, which, well, project-based education is an example of this, But in general, you could support any group, basically. You could also support a fraternity, for instance. We consider them to be our customers as well. As long as the members are part of our community, then they can use this tool. And we, of course, especially support the serious applications. But student associations are welcome to use this. I want to stress again the importance of having more than just a web-based tool. And one of the statements I dare to put here, and many people agree with me upon, is that presence is nowadays a very important starting point for any session that you want to set up. Well, messaging is an obvious one, and voice over IP has become one through Skype. Skype has proven the ultimate combination, I think, between VoIP and presence. And you can build this further with whiteboarding, which has already been known as a component in the messenger. But you can also jump to this environment that I'm presenting through from Windows Messenger, for instance. And our goal will be not to have a standardized way of instant messaging and presence, which are standardized through different protocols already, but to extend this and to make more possible than just sending messages. And it's not just something that we believe in. It has already been proven that voice is a valuable addition to just chatting, especially when it comes to discussing difficult problems. Chat is not enough. It's oftentimes the chat is oftentimes used as a start, and if it becomes difficult, then people start discussing, prefer to discuss it synchronously, I would say. And so far, many of you have probably been working in the area of video conferencing, and though the use is growing steadily, it still hasn't reached this massive group of people that we always hope for. So we think that if we can make video conferencing low threshold, like this, just having an ordinary webcam and a built-in microphone and a headset, then it will probably be easier for people to start using this and to overcome any problems that they foresee, like, for instance, seeing their own face. And so far this has proven to be true indeed, especially the use of the software and installing the software, which is the last statement. The easier the installment, and I think Messenger is an important example, which just comes with Windows. We all have our thoughts on that, but it proves to be the first and most important step for people to start using it. And we, of course, want to promote video conferencing, and we are putting this next to our high quality, well, we consider H323 service, we have a high quality service, and we want to integrate this environment and the H323 service because we think that there should be a growth path into the quality domain that H323 and SIP are offering. So SIP and H323 are a good bridge to the web conferencing environment that you see at this moment. It is a web-based environment, so you go to the server by typing in a URL, and then you can see everybody who's in a specific room at that moment. And you can see me talking in the upper left corner, and this image switches between the active talker at that moment. I can show you that it's easy to add some extra video windows, and I can drag some of the other video streams here. So I can see that you're still paying attention, which is very good, and eagerness there as well. Well, video conferencing is obvious in this case. Presenting a document is what you see right now, and it's also possible to do a lot of other stuff, like, for instance, chatting. You can see the word chatting now in the lower left corner. Sharing a whiteboard, something that is demonstrated a lot but never used actually. But application sharing and co-browsing are other important examples. I have to be honest and mention that we will not use Click-to-Meet in our future production service. We are looking into competitors' products like Breeze and Maritech, because the pricing model of Red Vision, who has bought Click-to-Meet, is not exactly scalable, let's put it that way. But we strongly believe that this is a good example of an environment that you can access very easily and use intuitively, and that integrates easily with other products. Especially SIP and H.323, because the server that mixes all the audio and video is basically an MCU which supports H.323 and SIP. So we could at this stage invite any GDS based H.323 station or SIP URL. I think that's a very good way of coming out of the proprietary domain and allowing anyone with any kind of station to join a meeting. Of course, not everybody would have the same facilities, as you can imagine, because in that case you would have to use a web browser to go to the server. The co-browsing thing is something that I can show right away, actually, if I skip onto this environment. I hope you can see this. Oh, sorry. I'll go back to the screen dump that I had of this. As you can see, it's not always going smoothly. I hope this picture gives a small overview of what it offers, but I think if you know a Yahoo group or an MSN group, or you may have seen SharePoint before, then it's pretty straightforward. There is a menu on the left side where there's items like shared documents, picture library, forum that you can install, you can make polls, etc. So this is all well-known material, and you can share this with any of the users that are available within your group. You can also adjust all the access rights for individual users as well. And what I haven't mentioned so far, but which is of course very important, is that accessing this site requires the same credentials as accessing the web-based video conferencing environment, and also accessing the presence and instant messaging environment. Here you can see that the ordinary Windows Messenger can be logged on to not just MSN or .NET Passport, but also to our own server. So SurfNet is sort of building its own .NET, which we hope forms a trusted environment for professors and university students, in which they can safely exchange maybe even their latest grades or new material, new college material. All right. So these are the three components, and as the arrow in this picture already shows, you can jump from the instant messaging environment to the web conferencing environment. And there's many other links between all of them. I foresee that will continue to for instance, share the same document space, because at this stage I got this document from the store that is incorporated on the web conferencing environment, and of course I would like to use it directly from the web-based SharePoint, in this case, environment. So the level of integration can be made a lot higher, and that's what we aim for in the production environment. So in general, the single sign-on thing was something that we strive for right from the start. And in the future, we want to extend that with A-Select, which is a shibboleth kind of, well, middleware people would start smiling now, but it basically enables people to log on using their own college account and not a SurfNet-made account. And then the interaction between the three is something that we especially have paid attention to, and which has proven to be very useful. I already mentioned the way that cross-platform support was provided. Presence and instant messaging is a difficult one in this respect. We've got a Jabber service running, We are also we have also started to deploy SIP and therewith Simple, which works pretty well. But clients in this area do not support jumping from easily between applications, which is something that we thought was important. Another thing is that the Department of Community Support, which deals with the end user, wanted to easily support their users and therefore wanted to join basically what they know best, and that is Microsoft Messenger. So since this is installed on every Windows XP deployment, they just have to fill in their account somewhere in the options, and they can join up this environment. So that's the weakest link in the cross-platform support, but we are discussing this with Microsoft as well, because we hope that this, of course, will be widely supported. Well, the team side is a different thing. It can be accessed with any browser, basically. There are some neat features, though, that can only be accessed through Internet Explorer because they require ActiveX, and those are little things like clicking on a person's name and inviting him into a chat session. And, well, as I mentioned, the web conferencing environment supports both H323 and SIP in the back end. In the 3 minutes left, I will tell you how the pilot went. Well, it went pretty well. I can elaborate some more, of course. We did it from October until April. It's still running at this stage, as you can see. And we hope to get 20 groups and 250 users, so an average of, 10 to 20 people per group. But, well, it has grown beyond our expectation, and we now have 87 groups and a little 700 users. We arranged it this way that there was a responsible person at every institution who was responsible for entering the user accounts, and later on, of course, in the production environment, this would not be necessary anymore. This whole environment was put on servers which are in a lab, which is not a production lab. Of course, in the future we will put it in a production environment. But the connection, of course, to our backbone is pretty good. So that's something that our customers valued a lot. And the connectivity to our network was such that they could use high quality video. What you are seeing now is medium quality, basically, just to be sure, of course. So the steps we are taking now is to design the architecture for the production service, and we are contracting maintenance organizations to host and support and maintain the servers and the software. As I told you, we are not continuing this web conferencing environment, so we are looking for the alternatives. We'll make a selection somewhere in the next 4 or 5 months. And then, of course, build it and promote it between amongst our customers. And I mentioned a couple of new features that we intend to install. The most important one is A-Select, and we still want to support SIP, of course, and the GDS for H323, and the Jabber connection on LCS, which, by the way, can be easily bought by a ready-made product. The common document storage is another one, and there are many other little features that our customers mentioned that we want to make them happy with. I hope that this makes clear what we intended to achieve with the pilot, and well, you can see that it works for presenting something remotely, very remotely, and it is flexible as well. I will switch back to the video conferencing mode in case there are questions, so I can see you as well. So, are there any questions?
Thank you, Eric. Are there any questions for Eric? Yes, the room is a lot wider than you see here, Eric. So there are people here, and they're all sitting on the edges.
Sorry, I couldn't understand that. Could you repeat it?
Is there any questions? So how's he hearing?
Seems that the presentation was clear.
Of Maurice heeft zijn microfoon gemute.
Okay, Ted, if there are no questions, then I would like to thank you for the opportunity.
There's one.
Oh,
Which
all right.
Can you hear us now, Eric?
Yeah,
Okay.
this sounds good.
There is one question.
Great.
I might have to repeat this. I'm not sure if they're going to pick up off that microphone. They're not
All
going
right.
to do this.
I haven't heard the question yet. So.
Hi, Eric. What's available for testing outside SurfNet?
Did you hear that, Eric?
I heard testing outside SurfNet, but I didn't catch the first
What
part.
is available for testing outside SurfNet?
I understood it, yes. Well, officially the pilot has ended, so I couldn't offer a group, which is basically the concept in which we offer this. But we have done that towards Internet 2, for instance, and some other foreign colleagues. I mailed it through the TFVC list, I think. So, well, actually what I want to say is that, yes, it was available outside SurfNet as well. In the future, we want to offer this service to any group which has at least one of our customers amongst them. And I think that for technical reasons and on a small scale, we can of course give access to people that we work with, especially people that are members of TFVC and Internet 2.
Okay.
I hope that answers your question.
Sure. Thanks.
All right, let's thank Eric.
Goodbye.
So we do a quick technical switch here. I'll introduce our next speaker, who's standing here next to me, Vasilis Hatzianakis. He works in the Network Operations Center at the National Technical University of Athens and is a researcher in the Network Management and Optimal Design Laboratory. And he'll talk about the use of reliable multicast for content distribution.
Hello. I'm going to talk about a content distribution network that we designed and implemented for the Greek school network. First, I'm going to make a small introduction on content distribution networks, CDNs. Content distribution network is used for delivering data inexpensively in terms of network bandwidth. They usually consist of one origin server and one or more levels of secondary servers. And they usually have two modes of operation, content replication or caching. When in content replication mode, the content is usually pushed from the source to the secondary, to the next levels. And the secondary servers get synchronized periodically. When using caching, the servers, upon a client request, get the data from the root of the tree. Here is an image of a typical CDN. Another point is that the content delivery to the end user is done by a redirection mechanism. Okay. So that the data is retrieved from the nearby server. So, what is the problem that we tried to solve? We needed to create a system that would distribute data inexpensively, that would be rather automated, and of course data has to be reliably transferred. Another point is the ease on management of the data on each server, like deleting and checking on the data. Okay, what we did is that we tried to create a system based on reliable multicast for transmission of data. The signal link for the synchronization among the servers is done either by unicast or multicast, but the transmission is done only in reliable multicast. The end delivery to the client is done through a redirection mechanism based on DNS. At this point, I will try to make an introduction on reliable multicast protocols. As you all know, IP multicast does not provide reliable transmission. There is a plethora of multicast protocols, reliable multicast protocols, because each one depends on the specific application. I mean that depending on the number of receivers and or the number of servers, the senders, or when we're interested in timely delivery rather than reliable or vice versa, we have to use a different protocol. So we have several categories of protocols. We have sender-initiated and receiver-initiated protocols. That's based on whether the server or the receiver is responsible for the congestion control and the retransmission of data when we have packet failures, packet loss. We have categories depending on the topography of the network, of the overlay network. We could have tree-based protocols or ring-based protocols. One very special category of reliable multicast protocols is the one that use forward error correction, and we will speak about them more because it's the one that we use. Okay, what is forward error correction? Forward error correction achieves reliable packet transmission without feedback from the receivers. What we do is that we divide data in logical blocks, and then every logical block is further divided in minus k packets. Then the sender adds k packets, repair packets, and transmits n packets to the receivers. That means that the source transmits more data than the original. For the receiver to successfully reconstruct the original data, the original logical block, it has to receive the first n minus k packets. Okay, what is the pros and cons of FEC? The great advantage of FEC is that there is no feedback from the receiver. The main problem in all the other protocols is that when trying to transmit data in networks that are heterogeneous, the performance of the protocol deteriorates. So the advantage of this protocol is a great scalability. However, there are a few drawbacks. The sender has to transmit more traffic, more data than the original. If the network conditions deteriorate more than it was expected, then data may be lost, may not be reliably delivered. And this is based on the FEC ratio, that is the ratio between the n and k number. One more point is that decoding is computationally heavy. Many of these algorithms are exponential to the amount of the data sent. So throughput is worse than in unicast transmission. So what is the architecture of our system? We used FEC, reliable multicast, for the data distribution. When multicast is also used for signaling, every server joins a common multicast group and this is the way they communicate with each other. When new content is uploaded to one of the servers of the group, then the server creates a new multicast group and starts transmission of the data. At the same time, it creates, it joins the common multicast group and sends advertising messages of the new content. So the other servers, if they don't already have this content on their directory, and join this group and start downloading the new content. The transmission ends when all receivers acknowledge successful delivery of the data. Meanwhile, they send ACK messages back to the source to show the progress of the delivery. As I said before, signaling can be done by unicast as well. Another point is that there is no origin server. All servers are equal, and the new data may be put on any of them. Another point is that an administrator can also delete content by sending messages similar to the ones that are called advertisements. Here is the scheme of the architecture. In the phase one, the new content is uploaded to one of the servers, the nearby server of the administrator. Then all servers get synchronized, and finally, clients can download the data from the nearby server. Here is an advertisement message. It is an XML message bearing information about the file or the directory of files and the multicast group that the receivers should join and to start downloading the file. As you can see there is an optional feature of digital signatures to assure that the sender of the advertisement is the one that says he is. This is an acknowledgement message. It's similar to the one before, plus a progress indication bar. Okay, let's see about the security consideration of such a system. What we try to do is to secure the CDN against modification of data. To do this, we installed access lists in the routers of the network, so as no one else but the servers can join and send data to the groups used by the CDN network. Another optional feature is the use of digital signatures. For the securement of the data of engagement modification, we could fake does the job for us, because if someone tampers with a packet, then the logical block will be discarded, and the receivers will have to download again the logical block. This may be a problem because it could result in a denial of service attack, but by using access lists, we fortify the system against such attacks. Now, about the implementation. The prototype was implemented in Java. It consists of some daemons that listen and send XML messaging for signaling, and a web interface for the administrators to put new data, upload new data to a server, and check the progress. It was initially installed in 14 core servers of the Endunet infrastructure. The Endunet is the Greek Scholar network. Each school of this network connects via ADSL or ISDN lines. The module that handles the file transfer, that uses FEC, is based on MCL, that is a multicast library. And finally, DNS redirection is done by the DNS bind views feature that was introduced in bind 9. This is a slide about the MCL library. It is a software based on ACL and FEC. ALC is a wrapper multicast protocol that performs, that uses FEC and performs also congestion control and multi-layer transmission. It provides an API for the multicast bulk data transfer. It is in C. So we had to create to connect it with Java via JNI. Now, future work. We in the first place we tried to have end-to-end multicast delivery, but that was not possible because the last mile, in the ASDN, we had problems with multicast transmission. Perhaps this would be a future work. In that case, each school has a Windows server, and that server, the domain server, that could use as the last replication server, the leaf of the tree topology. In that case, the CDN could use the push model from the top to the down, bottom up. That is that all download of patches and documents to the schools would be completely automatic. The first results of this implementation show that we managed to decrease the network resource utilization. The use of DNS redirection results to balance the use of server resources. Another key point of this system is that any server can use to upload data, and that was very handful in our network because an administration could be located anywhere in Greece. The distribution of data is semi-automated. That is that all the servers get synchronized, and then clients can download the data from their nearby server. By the use of this wrapper in Java, we managed to make the system foolproof against non-permanent network failures with the use of advertisements and retransmission of data when necessary. Okay, that was all. Any questions?
You said you stopped the transmission when the sending server received all acknowledgements.
Yeah. In fact, there's an option to stop the transmission after a period of time set by the administrator.
Yeah. But if you want to add a server, the sending server must know that the number of servers that are receiving has changed. Is there some kind of...
It's part of the configuration. When using multicast in signaling, each server has to know the number of its peers.
Yeah. Okay.
Other questions? Okay, thank you, Vasilis.
Okay, thank you.
Our next presenter this afternoon is Roger Bolam, who is the Content Delivery Manager for the Advanced Technology Group at UKERNA. While he's getting set up, I just want to remind you again to go either online or pick up paper copies of the evaluation forms and fill those out so the program committee and Terena staff can get your feedback on the conference program. It's all yours, Roger.
Okay, thanks, Ted. As Ted mentioned, I'm Roger Bolam. I work for UKERNA, which is the company which manages the Joint Academic Network, JANET. I work in the Advanced Technologies Group, and I'm currently Content Delivery Manager, so I do all things voice and video, so voice, video, and content, which is quite relevant what we're going to talk about today. Under content delivery and video conferencing, I'm going to keep it quite short and focus probably more on voice over IP. We've had a couple of three sort of major video conferencing developments in the last year, some of which are coming to fruition actually in a couple of weeks, so fingers crossed for those. Two things, JVCS On Demand and JVCS Check. These are, we have a UK-based video conferencing service called the JANET Video Conferencing Service, so that's an acronym for that, which currently supports around 450 endpoints, so a lot more users than endpoints. We have at the moment a couple of thousand. And these On Demand and Check, these two services are aimed at scaling out our video conferencing resources to desktops as opposed to video conferencing studios, and also to provide the ability for users to check the audio and video level of their video conferencing equipment. And access grid is hopefully a bit quite self-explanatory. Okay, quickly on content delivery. Previously in the last 2 years, we have been involved in what we've deemed the content delivery infrastructure trials in the UK, which has been looking at a number of content delivery streaming platforms. And as a result of this, we're now effectively involved in a number of UK initiatives, focusing really at the moment on audio streaming and download for the British Libraries, a project going on there. And much more in the sort of paper exercise area of things. We're looking to shape and produce strategy for future UK content delivery, focusing very much on streaming as opposed to anything else. We're also monitoring digital television developments. We see this as being a big sort of advent of content, but again, using digital TV. It's not on demand, it's just delivered. So we're looking at possible ways that we can take that content and deliver it over the internet. And a thing in the UK called Teachers TV, which is, strangely enough, television for teachers, to help them learn new teaching techniques and to have content which they can play out later to their students. Maybe looking to put this over JANET as well. Okay, so firstly, JVCS On Demand. I think in a similar sort of feature that we had this morning in the first session, video conferencing is now becoming very prevalent and is being used heavily. People want a very flexible and easy-to-use way of video conferencing. They don't want to have to, book resources for hours and hours in advance, or days in advance in some cases. They just want to get a webcam and a mic and start doing some video conferencing. So we've hopefully developed something which will satisfy that requirement. The JVCS On Demand service, it can be voice switched or continuous presence. So like today when you saw a number of people up on the screen, or you can have it voice switched, so whichever person is speaking they would effectively switch in. And the key thing about JVCS On Demand is that it's actually fully managed by the users. So the users have the ability to do any sort of video conferencing action they want to do. I'll cover these in a minute. This is how the homepage looks. This hasn't been launched yet, so that's why I haven't done a live demonstration. I didn't want to risk it going wrong. So it literally is a case of logging in. You can choose how you want to launch your video conference, search for people, add them in, and you see these green arrows of availability. This checks availability of the endpoints if they've been booked both in this system and our main JVCS system as well. That was quite a difficult thing for us to do. The conference is launched, and then you come to a managed conference page. The green balls here show that the connection has been made between our MCU, which dials out to the users, and the red cross shows myself there. I'm not connected. I can mute video. I can also increase and decrease audio. I can go into lecture mode and do exclusive speaker. I can move people around in continuous presence windows. And I can also bring people in and out of these sessions when I want to. This is all H323 based. We only adhere to standards and nothing else. So this has been why it's been a quite difficult thing for us to try and develop, because it isn't an off-the-shelf sort of product. Okay, so JVCS Check, another video conferencing tool which we've developed. In the UK video conferencing community, we very much like to make sure that audio and video level is within a certain threshold. So if you have a video conference with somebody, you know that their audio level isn't going to be very high, and you're going to have to fiddle with your speakers, and the same if it's too low. So and we also want people to know that when they switch their endpoint on, when they've just bought it, that it's actually going to work when they do a real video conference. So this JVCS Check tool is something which we've developed with the University of Edinburgh, who manage our video conferencing management centre for us. A couple of things there. The reason why we did it really is to improve the scalability of our resources at this management centre. They currently spend, each registered endpoint or video conferencing unit has to undergo a 30-minute quality assurance test twice a year. So with 450 endpoints, and this is growing now as schools, etc., come on board, you can imagine that we need dedicated staff just to do these quality assurance tests. So this tool is aimed to take a bit of the strain away from them. This is how the technology of the QA testing station looks. We have a Tandberg 6000 codec, effectively linked to an AMX controller. And we have a scripted DVD with a lovely lady who takes you through the quality assurance test. And we then have audio and video testing equipment which overlays the results of from these testing parameters onto the screen, the local screen of the user. At the moment, there's about 9 different chapters of this DVD, and each time a chapter finishes, the AMX control then kicks off the next action. It takes about 15 minutes, and the feedback so far is that it's been very good. Okay, quickly on another video conferencing theme is access grid. In the UK, we've seen this grow very heavily. We went from nothing to 35 nodes in a very short space of time, and now we have about 50. And these are all registered to use a recently created access grid support centre, which was aimed to effectively support and provide advice and help and assistance for access grid within the UK. There wasn't any central body doing that. This support centre also offers access grid, H323 and VRVS conversion facilities, so you don't have to effectively all have each standard-based equipment in your institution. You could use whichever ones you have and actually gateway to the other technologies. And these people are also starting to look at quality assurance testing as well, so another development area we're looking at. One thing outside of the UKNR area that's being done in the UK is a development to improve VIC and RAT, which are the video and audio tools used as part of Access Grid, and to also hopefully improve presentation collaboration. I know at the moment there's a few issues with interoperation of Access Grid software revisions, so we're hoping that this may sort out this problem. As for video conferencing futures, we think hopefully now we've got 323 pretty much sorted out. As I say, we've been offering a service on that for 2.5 years. It's continuing to grow. We're hopefully now making it more flexible. But there's things we still need to do and would like to do. One of those is the ability to record each video conference session and then have that played out later on as part of a lecture or as part of a learning activity or whatever. And also the ability to bring content into a video conferencing session. The key thing here is that the content that we're looking to bring in would be sort of MPEG, MPEG-4, maybe H.264 based, but we want to bring this in on an H.323 stream and not have to go and get another PC and fiddle around and try and find that, so it would be actually brought into the video conference. SIP video conferencing, you'll see in a bit that we're looking at SIP heavily for voice over IP, and we see obviously as SIP gets deployed throughout the UK, we're going to have to look at that for video conferencing as well. We're looking to improve the quality assurance testing for the Access Grid support centre in the UK, probably, maybe, hopefully by developing an automated system. We don't want to have the operators, as I say, spending lots of time doing this. And possibly in the future, the JVCS services, which I talked about at the start of the presentation, these may be fully automated using the technology we've developed for video conferencing on demand. Onto voice. Right, okay. In the UK, we've been doing a number of activities, both actual physical testing and sort of paper-based and discussion-based, and we've created what we're deeming the Voice Advisory Group in the UK, and this is a higher and further education represented group, and also UKON is involved, obviously. The aim of this really is to create sort of best practice and recommendations and case studies and testing environments for the Janet voice community. At UKON and as part of this advisory group, we've been testing both local and end-to-end, so WAN-based voice on Janet. We're looking to undertake a community voice survey within the Janet community. I think it's important to know what our customers want before we go and start developing things, so this is something we'll be doing very soon. We're considering which voice models we could potentially deploy on Janet, what our customers want, our connected organisations want, and we're also very carefully monitoring regulations at the moment. The goalposts for voice over IP, whether it falls into being a telephony provider or not, are moving very, very quickly. Okay, so just for those of you who didn't know, and to set the scene somewhat, traditionally a voice model may look something like this, which you have the PSTN, the telephony network, PBX at your organisation, and telephones hanging off that. And really, the voice over IP model being sold in a lot of organisations doesn't really differ much from that at all. So you just replace the VoIP, your traditional PBX and your PSTN with an IP network and IP-capable local voice switching equipment. But what realistically I think is going to happen is that, well, it is happening now. And these diagrams, I do apologise about my art, it's very, very low quality. You have both PSTN and voice over IP capability in your local voice switching equipment, and if you're calling other people on IP, you can do that. If not, you use the PSTN as you would do. So how is VoIP or voice being used in the Janet community? Well, we're a number of institutions, a lot more than what we actually thought, are replacing their local telephony switching equipment with voice over IP solutions. There's a number of reasons for this, and one of them might be the fact that manufacturers are starting to discontinue traditional telephony equipment and going with just IP solutions. People are utilising PCs with VoIP software clients. I've seen a lot of people here at the conference this last week using Skype, both for the voice and for the chat, and I'm sure if people knew exactly what was going on with the Skype clients, they may have not allowed that, but there we are. And people are also using IP networks to backhaul voice traffic. So companies, we have in the UK a company called Keycom who offers a solution to universities, halls of residencies to effectively take their existing telephony network for their halls of residence, converts it into IP, routes this over Janet, and then routes out from a known point in the UK. In this case, it's Manchester. And what this actually does is lowers the cost of transit for the universities because they're using Janet for that part of the call. And there's a number of those scenarios that are going on like that at the moment. A key thing to point out now is that obviously voice over IP uses a packet switch network which is shared in best efforts, where traditional telephony uses circuit switch networks which are dedicated and predictable. So we're going from a known, comfortable, quite warm environment to something which is quite bleak and unknown and isn't really designed to carry voice traffic, but there are ways in which you can ensure that it actually happens. So VoIP today, well, when I wrote this presentation a month or two back, there was 23 million users using Skype, and we're getting 15,000 new users per day. So this is something that can't be ignored and is obviously a very, very good technology. VoIP equipment is now very widespread in the Janet community in the UK, but this is very much on an inter-organisational basis. So what I mean by that is that universities are using it to replace their traditional local area network equipment and possibly talk to campuses, but not necessarily out on the internet and talking to other people. And traditional equipment suppliers, so traditional telephony equipment suppliers such as Mitel, Avaya and Ericsson are starting to come into the voice marketplace. So it's probably quite safe to say that this is happening and we should do something about it. Traditional telcos are also starting to route their voice traffic over IP networks. Please don't quote me on this, anyone, but BT in the UK has made a statement that by 2010 they'll have 80% of their voice traffic will be on BT's IP network. So people are buying into this technology. So voice over IP on Janet, well, as I discussed earlier, Janet, which is an IP network, is a best efforts IP network which does and can support VoIP. UKerner definitely isn't a telecommunications provider at the moment. We are a network provider, and that's it. But saying that, voice traffic is routed over Janet every day and is growing and increasing. And we're going to continue development work to ensure that this happens in the best possible way. So in the UK and in the EU, there are a number of regulations, well, actually a hideous amount of regulations linked to voice over IP and whether you're actually providing a telephony service or whether you aren't. There's 5 EU directives there, which I won't read out. The key thing is that these Ofcom regulations, these directives, and whether you're a telco or not, it's only applicable to certain types of voice service, so you have to do or not do a certain amount of things to not become a telco. And as we're watching the technology maturing and equipment sort of moving into this area, regulations are evolving and changing to reflect that. One important thing to remember in some scenarios as well, certainly within the Ofcom arena, a voice over IP handset, it may be a plastic block with a handset and a number key and obviously a microphone and speaker, but you have to have a label on there saying this is not a telephone. Because it isn't a telephone, you can't ring 999 services, you can't ring operator services, and it isn't guaranteed. So although something which looks like a telephone actually isn't necessarily that. In the UK, the differentiation between becoming a telephone provider and being not a telephone provider is this thing called PATS, which is PATS, the publicly available telephone services. In the UK, if you provide a PATS, if you do these 4 key numbers down at the bottom, the 4 key criteria, down at the bottom, you become a PATS. If you don't do those, but you still provide voice communications, these are classed as being electronic communication services, and they're regulated the same way as email. So although you're allowing your users to carry voice traffic on your network, you avoid those 4 things, and it's regulated in the same way as email. So that's where we are at the moment. And if you are a PATS, you have to do things like provide 999 services, operator service, and have very strict availability criteria. And obviously it's quite almost impossible to do that on a pure IP network. The 4 things that obviously define the PATS is a service which is available to the public. To start off with, this is when you have a sole telephone and you don't have the ability to have any other telephone. If you just have one telephone on your desk, then this is how it stands. So it's a service available to the public for making and receiving national and international calls with access to emergency services and through an official number, national or international numbering plan. So any of those 4 things and you become a telco. So with all of these challenges and issues that are coming up, often the questions asked is why voice over IP? I wouldn't say now that really you get a good return on investment for voice over IP at the moment. It obviously really depends on your local situation. I think on greenfield sites and new build campuses and buildings, it is worth investing because you only have one infrastructure, you only have your data infrastructure, which also carries your voice traffic. But it's potential cost saving in the longer term is the statement we're making. Again, as I mentioned, you converge your data and voice infrastructures. You only have a data infrastructure, not a separate one for voice. Depending on your local equipment, you also have the possibility of having lots of nice features, things like voicemail, email to you, and news and weather on your phone, and all the other things that come with having effectively a communication device on the internet. Again, as I mentioned earlier, voice manufacturers may start forcing the issue. A case of evolve or die. in the UK, there may be a slight worry that people are going to have to buy equipment cards and new chassis and upgrades for their existing PBX equipment from eBay because literally manufacturers are stopping support for products to attempt to force users to upgrade to voice over IP. And mobility, I think it's a very important thing. You effectively, wherever you are with your laptop connected to your local site's PBX, you have your desk phone wherever you are, as long as you have an internet connection. So that's something voice over IP provides, which is very good. So from the work we've done so far in the UK, and we think this is probably going to change, but at the moment, if somebody asked us what possible services could you offer, we would say these three things. One is a SIP-supported service on Janet with a provision of directory services to allow people to find each other. So effectively, we provide an infrastructure on which SIP can operate. And then through this central directory server, people can obviously find each other. The two grey boxes have to be standards compliant, they have to be SIP compliant in their nature for this to work. And again, there's a backup of having the PSN link there as well. We could try and provide to our campuses wishing to use voice over IP, we could try and provide advice and central support for interconnecting local IP voice switches. So something, for example, like a Cisco call manager could connect to another Cisco call manager, depending on the version number of software, across Janet, and would be able to call endpoints outside of its local area. And this is okay when you've just got two endpoints. So in this case, we've got Oxford and Reading. You just have to update Oxford's box with Reading's information and vice versa. But when you start having more endpoints and more PBXs involved, it ends up a full mesh or a full mess, really, and isn't something we can manage from the core. And I think local PBX managers at these universities will get very annoyed trying to update their equipment with everybody else's PBX equipment. So that isn't really scalable, but it's something that we can do. Or we can deploy and manage some sort of central VoIP switch with the ability to distribute tailored clients and also other clients connect to us using standards-based stuff. It's probably likely that something we would deploy would be the last point here and then the second point, so with a SIP directory as well. And this would look something like this, with these blue phones here being something like a Skype software endpoint. So we can distribute these from a central server to the users, and the users can then communicate with each other. But that's not really good enough, because we know that obviously people aren't going to use laptops for their work phones, and they want normal phones to exist in this environment. So where we're looking to be, and we think there's a number of products out there now and offerings from manufacturers, is that we can have a central Janet Voice SIP server. We can bring in SIP-compliant PBXs, SIP-compliant telephones, and obviously distribute software SIP clients to laptops and desktops and whatever we want to do. So as long as the SIP standard is adhered to in some way, this solution can work. From our work so far, again, things to consider and things to look at are that the choice of local VoIP equipment is very important, is actually critical. Before going out there and buying equipment, think about not only how it operates in a local area environment, but also its support for external communications and its support for SIP or H323. So it's support for SIP or 323 in a standards-based environment, including the manufacturer's interworking. So different flavors of manufacturer SIP here potentially. Addressing and numbering is something obviously to think about, but this is probably something which should be driven centrally, like it has been for video conferencing. Mentioned earlier the GDS. Something like this may come about. And the breakout into the network, the provision of these 999 services and operator services should probably remain with the telcos and at the local institution. So if you want to call somebody else on Janet, who's part of this service, do that over the network. If not, use your traditional PSTN. One of the interesting areas to think about was that we found through our investigations that where does this VoIP technology actually sit within the organisation? Traditionally in the UK, telephony has sat with estates and buildings, and obviously IP type applications have sat with data and network managers. And all of a sudden, these two areas that didn't normally ever speak to each other, and one doesn't know about the other necessarily, have got to try and come together and come up with some sort of agreement. So that's actually been a barrier for a number of UK institutions. If you want to know anything else, email either myself or Aaron Bowley, whose email address is here. He's the guy who's been doing all of the voice over IP work at UKERNA, or visit the ja.net/development website and choose content, video or voice from that. And that'll provide you with some more information on what's going on. And any questions?
Okay, Maurice Domen from SurfNet. You said JNet is a best effort network. Have you considered a QoS implementation?
I'm not the person to speak about QoS, but yeah, yes is the answer, and there is work going on at the moment. In fact, the talk next is from Victor Oliver, who's talking about this. SuperJANet 4 is a best efforts IP network, but obviously SuperJANet 5 is coming around the corner, so who knows? But yes, we have considered QoS.
Yeah, Dirk Kutscher from TSA in Bremen. I have a similar nasty question. One issue that frequently comes up when talking about providing web services on a large scale is that of security. Do you have any opinions or considerations of the importance of providing security, or any mechanisms you actually deploy today?
Yeah, is this for voice and video and anything really with web-based services, you mean? Or specifically?
For example, if you offer web services for a whole campus, do you provide any security mechanisms today? Or?
Yeah, okay. Well, anything that's at the local campus, that would be the security policy would be up to the local network manager and that site to obviously deploy themselves. Offering a central service like the central JANet voice switch, we'd obviously have to make sure that was fully secure. But in terms of security as well, is that if we were to develop the JANet VoIP client, it wouldn't behave like Skype does, in that it wouldn't start using up other people's bandwidth when they weren't on their phone and that sort of thing. And it would be login based. You'd have to have user credentials to be able to use that. Probably link it in with something in the future like Shibboleth, and at the moment it might be Athens to get access to those services.
Okay, thanks.
Raimondas Tuminauskas, LitNet. And, well, another aspect of providing voice services is the connection, call routing with another PSTN providers. Are you considering this in your network as well?
At the moment, no, because that makes us become a PATS or a PATS. So if we provide any PSTN routing ourselves, we become a telco, and at the moment we're not set up to do that. But that's not to say that the future won't be any different. Who knows?
Okay, thank you.
Jan Katz-Net. As colleague mentioned, peering the PST networks, do you think about peering with another NRANs or something like that? Do you plan to build your own E164 or enum directory or something like that?
Yeah, very much so. What we've done at the moment is very much been trying to actually understand what this technology is and what the implications are on UKERNA. But we're obviously a member of TF-VVC, and like the video conferencing side of things, it's critical that people come together from around Europe, and with anything that we did, we'd ensure adhere to a numbering addressing scheme which worked across Europe and like potentially the world for other NRANs.
Any other questions for Roger? Okay, let's thank Roger again and all the speakers today. And to remind you again about filling out the evaluation forms, and I believe the buses will be leaving at 5:45 from outside.